Hi class 12. So it's been so long. So anyway, let's continue our syllabus, right? So today we'll start chapter number 4. So write down chapter number 4, that is moving charges and magnetism. Moving charges and magnetism. Very interesting chapter. Okay, if you concentrate, then this will give you interesting fact about this moving charges and magnetism, right? So in your previous study in class 10 standard, you have done that if a wire is there and current is moving, isn't it? Current is flowing, then there is obviously charge is there, isn't it? Charge is moving. So at that time you'll get the magnetic field around this wire, isn't it? So you know this one, isn't it? This is your magnetic field, right? So this experiment was done by Oster, isn't it? By placing a needle, isn't it? Needle, isn't it? Compass, north pole, south pole. Okay, it deflects, isn't it? Right, it deflects. If there is current, then this will deflect. Okay, so this is done by our famous scientist Oster, isn't it? Right, Hans Christian Oersted. Okay, in the year 1820. Okay, so what he conclude is that moving charge or current, what he conclude is that moving charges or currents produce a magnetic field. Produce a magnetic field, right, in the surrounding space, in this surrounding space, in the surrounding space, right? So turn page number 132. There you'll get. Okay, so you know how to find this direction, and by thumb rule, isn't it? By screw rule, isn't it? Clear? So you know those are the things. Okay, so next write down magnetic. So direction, you know, isn't it? So arrow, this means any field or current going inside the, sorry, coming outward, isn't it? Towards you, isn't it? यस्तो छ भने के हुन्छ, कुनै पनि field या कुनै पनि quantity comes towards you, isn't it? Outward. यो पनि पढेको छ. If there is cross, then this is going down, isn't it? Going into the paper, isn't it? यसरी जाँदैछ perpendicularly. So this is inward. Anything, okay, direction of current or direction of field. Okay, so these are the symbol. Understood? So these are too convenient, isn't it? Right. So next write down this magnetic force. Okay, first we'll start magnetic force. Magnetic force. Magnetic force. So subtopic, write down sources and field. Okay, magnetic force. Under this you have topic sources and field. Sources and field. Magnetic field त छ भने हामीले चाहिँ नि, so magnetic field and source. Okay, so you know that see, this is your charge, moving charges, current is there, isn't it? In your previous study, you know this electric field, isn't it? Equals to how much? Q by 4 pi epsilon naught r square, isn't it? In your book you have r cap. This is direction along with the direction vector. Okay, so we are finding here, isn't it? And You also know that F equals to how much? Q of E, isn't it? Done, isn't it? Due to charge, isn't it? Charge is there, isn't it? Let us say static charge, isn't it? Right. So and see, this is the field, isn't it? Electric field. So moving charges also make a field, isn't it? What is that? That is magnetic field. Magnetic field. And it is denoted by capital letter B, okay? Magnetic field is denoted by capital letter B. And this is also a vector quantity because this is the direction, isn't it, of magnetic field, isn't it? This is current and this is the direction of magnetic field, right? बुझ्यो कुरा? यो फिल्ड कोले बनायो? एउटा चार्जले बनायो, हामीले पढ्यो फर्स्ट च्याप्टरमा, isn't it? तर magnetic field चाहिँ केले बनेको? मुभिङ चार्जले बनेको, ओके? क्लियर? So moving charge भनेको के हो? Current, isn't it? Current is your flow of charge, isn't it? So if I have charge over here and if I have current like this, so then you will not get magnetic field, isn't it? Why? Because this is static. If this charge moves, okay, with the velocity v, then only you will get magnetic field. जब चार्ज बसिरहन्छ त्यति बेला you will not get the magnetic field. तर कति बेला पाउँछ? If the charge moves with the velocity v, then only you will get magnetic field. यो बुझ्नु पर्छ ल नानी. Understood? So magnetic field is due to motion of charge and current. Clear? Electric field is due to static charge, isn't it? Right. So next write down magnetic field Lorentz force. Lorentz force, very important. Done this one. So next write down Lorentz force. So write down field, understood, isn't it? Which is due to current carrying element with moving charge. Okay, charge चाहिँ के भन्छ? Move अगाडि भन्दैछ, टपिकले भन्दैछ, isn't it? Chapter also says that moving charge, isn't it? So write down Lorentz force. Magnetic field you understood, isn't it? Magnetic field. Next, Lorentz force. See, if a charge is there, Q is there, and moving with velocity v, velocity of this charge is your v, with the time t, and there is a magnetic field, isn't it? Where magnetic field is there already, isn't it? So magnetic field B of R. If you find force, you'll get force on this charge with this and moving charge, isn't it? So you'll get how much? Q of ER, electric field due to this charge, plus velocity of this charge into the magnetic field. So this is your force, okay? Lorentz force. This is called Lorentz force, and this is also equivalent with F electric. This is your electric, isn't it? Q into ER, plus this is your F magnetic. Clear? So this is your Lorentz force, okay? So turn page number 134, okay? There here you have the features of this Lorentz force, okay? Here मजाले लेखा 1 2 3 तीनवटा छ, okay? So first feature says that it depends, the force depends on charge, the velocity of charge, and the magnetic field. This force will depend on charge, velocity, and the magnetic field. Clear? Second says that, second significance is that magnetic field, that is your Q V cross B, with the velocity of charge and the magnetic field, isn't it? Includes the vector product of velocity and magnetic. This is due to, this should be in 90 degree, okay? के भन्नु चाहेको भन्दा यो V र B चाहिँ velocity of this and velocity of direction of magnetic field चाहिँ कति हुनुपर्छ 90 डिग्री बनिनुपर्छ यो चार्ज उम्पुकुल्दै गरेको हुनुपर्छ ओके नेक्स्ट magnetic force is 0 if the charge not moving यो चार्ज चाहिँ मुभै गरेको छैन भने यो चार्ज नट मुभ गर्यो भने के हुन्छ F magnetic field छ नि सरी magnetic field चाहिँ के हुन्छ 0 हुन्छ यो velocity 0 भयो भने यो 0 हुन्छ हुँदैन so this is your significance. So from here you will get F equals to, now very important, from here you will get F equals to Q V cross B. Those are omitted, isn't it? R and E is omitted. Why? Because E is there already, isn't it? Field त यसको छ नि त हैन. So this equals to how much? Q V B into sine theta. Okay, why sine theta? This angle between V and B, this is your B and this is the velocity of the charge Q. So this should be 90 degrees, isn't it? So sine 90 how much? Sine 90 is your 1, okay. Cos 0 is your how much? 1, isn't it? So sine 90 हुनुपर्छ नि sine 90 कति हुन्छ 1 हुन्छ check your identities right sine कहाँबाट सुरु हुन्छ यस्तो छ नि त हैन this is your cos कहाँबाट cos 0 कति हुन्छ 1 यस्तो हुन्छ तर sin 0 चाहिँ कति हुन्छ 0 sin 90 चाहिँ कति हुन्छ 1 हुन्छ pi by 2 clear so right so if you write this in dimensionally you will get F equals to how much you will get so F equals to F equals to how much you will get F equals to Q V B so dimension isn't it so B equals to how much B equals to F by Q V clear put this up so this is your magnetic field now find unit of magnetic field is this one isn't it so magnetic field is denoted by B and unit of this is your Tesla direct like that नभए force को के हो coulomb isn't it so Newton isn't it force को के हो Newton second velocity को माथि जाँदा के हुन्छ second माथि हुन्छ divided by coulomb meter charge को के हो coulomb velocity को meter per second so this is also called Tesla okay so why the unit of magnetic field is your Tesla because Tesla our famous scientist done this derivation so this is your Tesla right so SI unit of magnetic field is your Tesla okay Tesla चाहिँ के हो SI unit अरु पनि छ Gauss okay Gauss okay these are non SI unit clear so next write down magnetic force on a current carrying conductor so you know this one magnetic force on current carrying conductor so this is your combined force isn't it Lorentz force is your combined force now on current carrying conductor isn't it so this is your conductor where current is there isn't it I is flowing so you have to find magnetic field isn't it so if I say this is your area E and length is L then what happens so number of charge this one you done isn't it so how much F equals to how much Q V into D isn't it so Q charge how much N E L and velocity is your drift velocity over here isn't it drift velocity into B clear drift velocity previous chapter we have done isn't it cross section area length number of charge how much N E L velocity dv vd isn't it drift velocity So if you calculate this one, you'll get F equals to N Q V D into L, A लाई बाहिर निकाल्दियो into B. So you'll get F equals to how much? I L into B. Book मा हेर भेटिहाल्छ तिमीले. Page number 136. Okay. So this is the force on a current carrying conductor. Right. So now अब के गर्छ तिमीहरु? Example 4.1. Just write it and do this one. This is your current carrying conductor. Magnetic field is going down, isn't it? Cross section. So going down. So you have to find the force on this, isn't it? So how much? Mg equals to how much? IBL. Why? Due to gravity, isn't it? B is there. So B equals to how much? Mg by IL. So I is given. G you know 9.8. And this length is 1.4. So this much of Tesla. And this one you can do this one. Velocity is this direction, magnetic field is this. Then what to find? You have to find the direction of this one. Clear? So now next topic is motion in a magnetic field. Very important. Motion in a magnetic field. सजिलो छ. Next topic is motion in magnetic field. सारो आकै छैन हो के. सारो त आकै छैन. सारो त law देखि सुरु हुन्छ. That is your Biot-Savart law, okay, or Biot-Savart property. So write down magnetic field. Motion in a magnetic field. Motion in a magnetic field. So draw this one. If you want to draw this one, draw it, isn't it? So B is going downward, isn't it? Like this one. This is your magnetic field going this way, isn't it? Magnetic field. Now you have a charge, isn't it? Positive charge over here. Let's see. And this is also moving like this. This is the direction of velocity. Now this is your, let us take center, okay, and this is what? Circular. This will move in circular path, isn't it? Force के हुन्छ centripetal लाग्छ, isn't it? So this will not go like this. Due to magnetic field, it will move like this. Why? Because screw law, isn't it? Field and screw law you can do, okay. And if you this is your radius r, isn't it? So at that time you have to find what are the things, isn't it? mv square divided by r is equal to qvb, isn't it? So at that time you will get r equals to how much? mv by qb. This is from 11, isn't it? Centripetal force, isn't it? mv square by r equals to this one. Clear? So if you clear, then do this one. What is the radius of path? Example number 4.3. This is also your homework. सकिन भने भन्नु ल मलाई. Now you have the topic velocity selector. So you अघिको लेखा, then you will get this one. Q E equals to how much? QVB. Okay, this is your velocity selector equation. Clear? So see, this one is not in your syllabus. Cyclotron पढ्नु पर्दैन न, cyclotron पढ्नु पर्दैन. So your velocity selector मा चाहिँ के गर? What you will do? Just draw perpendicular. Okay, सबै ij क्युब गरेको छ. 11 मा अलिअलि याद छ होला. QU I X I Y Z I J K, okay na? Or you can write so this is your E, direction of E, electric field. This is your V, and this is your B. Okay, सबै के हुन्छ परपेन्डिकुलर हुनुपर्छ किन sin 90 हुनुपर्छ isn't it सबै परपेन्डिकुलरमा भयो भने के हुन्छ फोर्स लाग्छ ओके so if you do the cross E and B field therefore serve as velocity selector cross E cross B छ नि E cross B यो दुईटालाई चाहिँ के भन्छ velocity selector भन्छ ओके so cyclotron you don't have to do this time this cyclotron now last year I have done what this is what the magnetic field is there isn't it so if you project a proton or any charged particle over here it will move like this okay accelerated okay so you can read okay this is not in your syllabus okay just omit this one so next time tomorrow or Wednesday tomorrow is Wednesday okay so tomorrow we'll do this one this is very important Biot-Savart law from here your class is started so this much for today so hope you're doing good okay so